Good morning, one and all. Today we discuss about 1.7 bits. Okay, going to this class, we want to discuss in the previous lecture or previous class, that is standing wave or stationary wave and normal modes. Okay, what is the standing wave? When a progressive wave is traveling in a with speed v, and at a certain time it can be travel in the opposite direction. The resultant wave is constant, does not change with the same frequency. It is a one wave is traveling like this. It can be after this reached the point, it can be reflect like this. It is a standing wave with the same frequency. Amplitude is same, frequency is same, velocity is same, time period is same. You can this type of wave is called standing wave. Okay, in the case of the stationary, in the case of standing wave, nodes or antinodes will be formed at maximum amplitude nodes. This is the one wave like this. These are the minimum amplitude. Minimum amplitude means minimum displacement is called nodes. This is node. The maximum amplitude at the middle, that is antinode. The distance between the node, antinode to node, is lambda by 4. Node to lambda by 2. This is a lambda by 2, and also antinode to antinode is lambda by 2. Okay, this is a previous class. And also we can finally relation between the frequency and length of the wave, lambda n for n to L by n. And also in the form of frequency for n waves, frequency, now modes of vibration, that is n nu by L or n nu 1. This is the frequency of nth waves. Okay, now we discuss about beats. Beats is a phenomena of interference of waves. It is a interesting phenomena arising from interference of waves. When it is occur means when a two harmonic sound waves are nearly equal frequency. This is the one wave frequency. Another one having same nearly equal to frequency. This resultant of these two waves are approximately same equal frequency and traveling in along the same direction. They will be superposed. They will get the one resultant intensity of the wave. This it can be gives the one wave. This type of wave gives the one is minimum, one is maximum, one is minimum in periodically. Periodically means 1 by 1, 1 plus 1. Okay, thus this phenomena is called beats. Beats means like this. This is a sine wave. This is the wave. Okay, this wave is beats. This is a one frequency. This is from a this frequency in bit 1, the beats will be appear like this. Okay, this type of phenomena is called beats. That means minimum, maximum. That means minimum and maximum, rising up and down. This phenomenon, they both will be interference. Interference means superposition of two or more waves come, and the resultant displacement vector resultant wave is from a resultant wave. This type of phenomena is called beats. Okay, here there are regular rising means upward, increasing the intensity of the wave and decreasing the intensity of the sound wave. One rise means like this: one rising or while increasing, decreasing, one increasing, decreasing. This is the it is a it is under the beats. One beat consisting of one maximum amplitude, one is minimum or maximum intensity, minimum intensity of the wave. This is called one beat. One beat consisting of one rising and means increasing of intensity, falling of intensity, decreasing of intensity, like this: increase, decrease, increase, decrease, personally only decreases. This type of phenomena, it is one beat. One beat consisting of one increasing, one decreasing of intensity, it is a one beat. Okay, graphically instrumentation of the beat is shown like this. This one wave is traveling in the x direction. Okay, from this to here, one wave, two waves, three waves, four waves, five. Okay, n is equal to number of waves is forming, frequency number of beats or number of waves 5. Next, another wave is forming with two different frequency, small change in frequency. Okay, like this: 1, 2, 3, 4, 5. From ear to ear, one wave, ear to ear, two wave, 3, 4, 5, 6, 7, 8. 8 number of beats is appear here, or number of waves or number of beats 5 here v. Okay, we can changing them, we can form a resultant displacement, resultant wave of the two waves is like this. This combination of wave gives the this resultant wave. This type of phenomena is called beats. The difference is frequency to between difference of the two wave is, suppose 8 hertz, it is 5 hertz. Difference is f2 minus f1, that is 8 minus 5 is equal to 3 hertz. That is a number of 3 beats. Number of 3 beats are appearing. Okay, this is the number of forms. Number of beats will be occur. That means beats will be appear. Suppose here two harmonic waves like this. One wave having frequency 5. Okay, another wave in frequency having 5, frequency 8 hertz, giving rise to beats frequency 3 hertz. The beat frequency is nothing but difference of the two frequencies is called beat of frequency. The frequency difference is f2 minus f1 is 8 minus 5, that is the 3 hertz. That is the beat frequency of the wave. This is the beat frequency of the wave, resultant wave of the two waves. That is the one wave is 8 frequency, another one is 5 frequency. Give you the beats of frequency is 3 hertz. Okay, they having some conditions of the beats. That is, they having sound resonance in occur brain in 1 second. Okay, hearing we can't hear the brain without 1 second. There is a number of sounds. Okay, we can measure the, remember, sound remains in our brain for 0.1 seconds. Okay, after 0.1 we can measure the identify the number of sounds in a brain. So we can distinguish between the two sounds if after 0.1 second, we can identify the number of sounds. That is the beats. Beats is nothing but it gives the number of waves. Waves is coming means it can be having difference frequency differences. It can be due to the sound, number of musics. Okay, this type of is called beats. Okay, here at 0.7 seconds we can't distinguish into different two types of sounds, or two or more sounds can be not identified. Okay, this internal difference, time interval difference. Okay, you know difference, what is the relation between the frequency and time? Okay, what is the time? This time we can listen the time is 0.1 second. That means 1 by 0.1, that is 10 hertz. The range of human listening or hearing the sound is 10 hertz. 10 hertz of the frequency. Okay, that less than 10 times we can count frequency differences between the two waves is less than 10 hertz. We can identify the sound of the waves, that is f2 minus f1 less than the 10 hertz. Can identify or hear the number of musics, and also sounds can be appear in the waves, that is wave is called beats, can be measured within difference. The frequency is difference is less than 10 hertz. Okay, suppose if beats, okay, like this, if can 10 below the time period frequency is below 10, you can easily identify, and beats can be produce the sounds, different sounds we can listen, and comfortable to listen or heard number of musics or sounds. Okay, that is frequency. Okay, suppose if the frequency difference is greater than 10 hertz, suppose one wave having 200 hertz, another one is 400 hertz. The difference is f2 minus f1 is 400 minus 200, this 200 difference edges. Okay, that is this frequency is above the 10 hertz. 200 frequency is above the frequency. That is this frequency we can't appear in the, we can't difficult to listen to the sound from the beat. So that is why there is no beats can be formed. That means this only one type of beats can be appear, not like this decreasing or increasing. Like the beats is nothing but rising or falls, or increasing decreasing of the intensity of the wave cannot possible in the wave, because the very difference is the frequency difference is very high compared to two waves. So the beats cannot be get the sound, and get not possible to hear to we can listen or heard to the sounds of the beats. So the the difference between the two wave frequencies is very approximately equal or nearly equal, that is less than to the 10 hertz. They can be producing the sounds, different musical sounds, tunics that is can be favorable to human bodies, or listen to other different sounds. Okay, here there is no textbook, we want to measure the mathematical expression of the beats. Okay, there is no textbook, but it is important. It is need to explain. You want to it is not for necessary. Okay, you can consider here two amplitude waves, that is one having same amplitude, they having two waves. Suppose here one, another one, same amplitude, same velocity, but only change slightly small frequency. First have a wave having frequency 1, number 2. Okay, they having the, we can write the displacement wave equation. First wave y1 is equal to a sin omega 1 t. Second wave displacement wave equation for second one, for second one. This is y1, y2. Okay, a sin omega t, only changing the omega means frequency. Frequency it is new 1, new 2. Okay, we can, they are superposition. Superposition of principle is y resultant vector v or y is equal to y1 plus y2. These are we can write the s1 plus, also in the case of textbook, s is equal to s1 plus s2. We can write the displacement equation in the form of s or y. Okay, the resultant vector like this. We can simplify these two equations. We get the solution. Y resultant to wave equation is equal to a dash sin 2 pi nu 1 or this one. Okay, comparing this one, when it is maximum, when it is maximum, when it is minimum. Okay, we can multiply it like this. Amplitude will be maximum. If it is possible means here, see here, in the case of equation, the resultant vector 2a cos omega 1 minus omega 1 minus omega 2 into sin omega 1 plus omega 2 by 2. Okay, suppose we can take this parameter. The graph is like this. The graph is like this. Okay, this is the resultant displacement vector. Displacement is 2a cos omega 1 minus omega 2 by 2 into sin omega 1 omega 2. Okay, we can simplify. Two parameters is there. One is this one, another one is this one. Okay, this is the AR, this is the B constants. Okay, we can draw the displacement versus AR, this parameter. This is like this wave. Okay, like a wave. Okay, suppose we can draw the graph displacement vector, resultant displacement vector versus B. This is sin omega 1 minus omega 2 by 2. This is the resultant vector displacement, that is y versus B. Y versus means y versus sin omega 1 plus omega by 2. This is the graph. Suppose you can draw the graph y versus 2a cos omega 1 minus omega 2 minus by 2. We get the like this. Okay, suppose we can draw the both cases. Y is equal to 2a cos omega 1 minus omega 2 by 2 into sin omega 1 plus omega 2. We get the like this. This is like this. This is the wave. This wave. These are the beats. Okay, like this. Minimum, maximum, minimum, maximum, minimum, maximum, minimum, maximum. Minimum and maximum can be, can be previous continuously process can be occur in the wave. This type of phenomena is in the beats. This equation is called beat equation. This equation is called y is equal to 2a cos omega 1 minus omega 2 by 2 into sin omega 1 plus omega 2 by 2. Okay, this is the equation. When it is okay, the phase difference is, suppose two waves are having small difference, suppose 20 10. Okay, suppose we can adding that frequency, it can be more than, it is not comfortable to the beats maximum or minimum. This is only possible. That's why we can take like this new, it is maximum amplitude in the form of frequency 2 pi nu 1 2 by 2. It is equal to the n pi 0 1 2 3 5. We can substitute the n number of n numbers. We get the time period beats, number of beats can be occur in the phase difference. This is the with amplitude will be maximum. Suppose we can do it the minimum, that is it can be 0. Minimize means here minimum, we get minimum at point at antinode. It is possible, it equation will be 0. The time is 2n plus 1 by 2 into change in frequency nu 1 minus nu 2. Okay, okay, that is a see here. The this is means class BB. Class B means like this. The difference between the two frequency will be I will take, because we can measure the frequency difference. We can, the bits will be formed. Okay, suppose we can adding the frequencies, it can be more than 10 hertz. That's why it is not occur in the beats. Okay, this is only applicable for difference of the frequencies. That's why we can take v is equal to 1. There is the intensity is related to the maximum and minimum. It is a maximum, it is upper, minimum is this one, minimum is this one, maximum is this one. Both will be beats equation. Okay, here from this equation we can find the beats frequency changes. That is the frequencies f1 minus f2 or omega 1 minus f2. This is the in terms of angular frequency. This is the in terms of frequency. Angular frequency is equal to omega is equal to 2 pi f. In terms of bit frequency, we can write down the bit frequency is nothing but change in frequency. Bit frequency is nothing but change in frequency. Frequency is nothing but change in frequency f2 nu 2 minus nu 1 or nu 1 minus nu 2. Change in frequency. The frequency is nothing but change in frequency nothing but higher minus lower. Okay, now we can studying the applications of beats. Applications of beats, they having number of applications in the music. Number of applications having in the natural life or human natural. That is some body, some of the mentions they having tuning. Tuning means you can get the different sounds. Stretch string also, we can stretch the strings, it can give them different sounds. They giving some sounds. That is the tuning of the musical instruments is given so different tuning, different sounds. This phenomena is called beats. The instrument has given different sounds like tuning of various instruments like sitar, flute, harmonic, etc. They are giving different sounds. They are giving musical instrumentation. Sitar is giving different sound, flute is different sound, harmonic is different sound. That is number of sounds are given various instrument. That is, it can be phase difference is small. They giving number of sounds. Okay, suppose some of the members are doing mimicry like this. They are giving changing its frequency. The frequency changes. The frequency changes. They get the different sounds. The sounds is nothing but difference of the two sounds. Suppose yesterday explained about the resonance. Resonance is nothing but see take about the standing wave like this. Standing wave means the resonance. The air of the frequency, tuning fork of the frequency will be equal at a certain time. The different sound will be occur. One type of sound will be occur. Thus, that frequency is called resonance frequency. That can be we can do in the general any way. Okay, that is the different sounds will be occur. When these instruments are used in made up of play simultaneously, they are producing beats show that they are not in a tune. Suppose they are preparing or made up by with changing small variation of frequency. Suppose simultaneously we can be producing the different sounds. Suppose the bit frequency changes is high, less than greater than 10 Hz. They do not give the any type of beats or sounds. Okay, they are the instrument can be made up of by frequency, made up by small variation of the frequency, small change in simultaneous frequency. Then they can producing the sounds. Because of the beats can be appear some sounds, so that they are not, suppose they are not given any type of sound till the frequency will be same. Suppose in this wave like this, another wave is like this. Same wave, same frequency, same amplitude, same wave, they give like this. The resultant displacement is a superposition of two waves. But in the case of like this here, in the case of this one, sorry, see here two different wave is different. Here same frequency, same amplitude, same velocity. The resultant displacement vector or the resultant wave is like this. Okay, they cannot give beats, they can't get the sounds or tuning. Okay, this is the difference. Okay, another important application of the beats, detection of the harmful of the gases in a mines. Okay, using beats we can detect the harmful of the gases. Where is the gas leakage, where is that, we can using the use the two small pipes. Okay, one pipe having atmosphere air, atmosphere means normal air. Another second pipe containing mine air. They get the mine here, they having different frequency, they get the detection of the harmful of the gases. Okay, suppose they having same air, suppose when the air is pure, we can't get the beats. Suppose main air and atmosphere air having same air, they will not get the beats of the sound. Okay, that is sound we want producing the sound. The phase difference, small difference in the frequency, both mine one pipe and mine another pipe having different frequencies. Okay, here pipes having same frequency, we can't get the any sounds, any beats. That is the that's why we want to remove the detection of the harmful of the gases when we using mines of the frequency, air frequency is different, we can detection of the harmful of the gases. Okay, now we can explain the one problem. Okay, example 1.5, a pipe having 30 centimeter long is open at both ends. Which harmonic mode of the pipe is resonance having 1.1 kilohertz source? Okay, will the resonance with the same source will be observed if one end of the pipe is closed? Okay, we can take the speed of the wave is or here is 330 meter per second square. Okay, now we can explain the problem. Okay, in the first case we can having L is equal to length of the pipe 30 centimeter. Okay, V is equal to 330 meter per second. Okay, first we can find the for frequency or harmonic modes of the vibration or frequency for open head to both hand, like this for both hand. Next one is resonance is occur, it observed one hand is only new for one hand open, another one is closer, like this. Okay, for we can measure the frequency for open pipe or organ pipe are nothing but one end is open, other one is closed. Okay, what is the frequency formula? Nu is V is equal to n lambda or nu lambda. Okay, nu we can write down mu in the form of frequency. Nu is equal to V by lambda. This is the relation frequency, velocity and wavelength of the source. Okay, for open pipe like this, from 0 to XL, the waves can be formed in the stationary wave like this. Okay, here the length of the loop is equal to wavelength of the source is the here L is lambda is equal to 2L. Okay, for open pipes. Okay, suppose we can find the frequency. Mu is equal to V by lambda is 2L. It is for only for first wave. Suppose we can substitute for n waves. Mu n is equal to n V by 2L. This is the frequency, number of frequency. We can substitute V value. V is equal to 330, L is equal to 30 centimeters. We can substitute. We get the frequency Vn is equal to n into V is equal to 330 by 2 into L is equal to 30. 0 0 3 11 11 5.5. Okay, you can terms the meter per second and write down the okay, suppose n is equal to 1, it can be 550 seconds. Okay, 550 seconds. Suppose we can take n is equal to 2 like this. Here n is equal to first mode. You can take n is equal to 1. Fundamental of first harmonic mode is like this. That is length frequency is having 550. Second is 550 into 2 110. Like this we can increase multiply into with n we get the number of modes of vibration. It is both ends are open. That is a open pipe. Okay, the second case is one end is open, other one is open. We can find the frequency. Okay, same formula. Okay, for this is it is formula, but in the case of open, both ends are open. This is the ratio of the nu 1 plus nu 2 to nu 3. Is the ratio is 1:2 3 like this natural. Suppose in the case of one end is arcon pipe, like this one end is open, another one is closed. The ratio of the frequency nu 1 nu 2 nu 3 is 1:3 5:7 like this. This is the natural number. This is the even ratio of the odd numbers. Okay, now we discuss about the frequency of the organ pipe. One end is open, another end is closed. Okay, same formula. Okay, but the length is different. The length is lambda is equal to 4L. The length of the wave is 4L. Okay, we can substitute the frequency nu 1. That is second case. Nu 1 is equal to V by 4L. Suppose for n number of n is taken for number of modes, n by 4L. Okay. So okay, suppose take again the ratio is 1:2. This is a hard pipe, that is organ pipe means one. The ratio of the frequency is like this 1:3 ratio. N is equal to 1 2 3 like this. Suppose we can take 1 or 3. Okay, suppose n is equal to 1. V is equal to how much? N is equal to, okay, first we can substitute the V value. N into V 330 by 4 into 30. 3 1 0 0 1 3 11. Okay, 4 1 7 4 4 4 2 8 3 4 8 4 to 8 remaining 3 3 4 9 4 8 okay there is a 280 2 like this 275 into n 275 n hedges for it is only for natural. Suppose we can take n is equal to 1, the first mode of harmonic in 275 into 1. Suppose n is equal to 3, that is new 3 275 into 3. Okay, n is equal to 5, new 5 is equal to 275 into 5. We get the frequencies, that is it is for open organ pipes like this. Here these are the organ pipes, one end is closed, another one is open. It is the first 1 3 7 like this ratio of the organ pipes, 1:3:5:7:9:11 like this. The this fundamental of harmonic vibration of modes in the ratio of odd numbers. Okay, now we will discuss another problem. Okay, here only explain. See, two stars having string 1A and B playing node. It can be producing the beat, the slightly out of tune producing beats frequency 5. The tension of the string is slightly increased. Okay, the beats frequency is found to be decreased 3. Okay, what is the original frequency of the B? If A frequency is 477. Okay, now see here beats. We can measure beats differences. Beats will upper. The difference is f2 minus f1. Okay, it is below to the 10 edges. Okay, suppose we can what is the first frequency of the beat? A is equal to 427. New A is equal to 427 edges. The difference is delta nu is equal to the frequency is 5 edges. Here 5 edges. Okay, the tension of this string is slightly increased. Slightly increased means, okay, what is the formula? Frequency 1 by 2L into T by mu. Okay, there is a frequency formula. T is the tension, is the length of the wave, mu is the linear density of the string. Okay, the tension is increases, the frequency also increases. That is, the frequency of the second frequency is greater than 427. That is why that is f2. Okay, increase, but f2 is higher. That is why 5. f1 is 427 minus f2 is equal to 5. Okay, yeah, sorry, f1. Okay, f1 here A means first one. Okay, that means f1 minus 427 is equal to 5. Here okay, f1 is equal to 427. These are will be same. 427 minus 5, that is 422 edges difference. Okay, suppose and also 427, suppose we can take plus or minus 427 plus 5, how much? 432. 27 427 plus 5, 432. Okay, suppose tension will be increases the frequency will be increases. Okay, frequency will be increases, but here the difference is verified, it is below to the 427. That is why 420 is the answer. Thank you, one and all.